Good morning everyone. I am Pavitra, Department of Mathematics, working in Erode Sengundar Engineering College. Today we all discuss about that contour integration. Contour integration. Contour integration means that the complex integration along the screw curve used in evaluating the definite integral is called contour integration. Okay, contour integration means that the complex integration along the screw curve used in evaluating the definite integral is called contour integration. Okay, so we already know that complex integration. Complex integration means that integral over c f of z dz. So here z denoted by x plus iy. So here I is an imaginary part. So imaginary part included means that variable is an complex variable. Okay, so is known that complex integration. The complex integration along the screw curve. So screw curve means that closed curve. The closed curve. This is the completely closed curve. Okay. The complex integration along the screw curve. The complex integration value along the closed curve. Okay. The closed curve means 0 to 2 pi. Used in evaluating the definite integral. Definite integral means that completely closed interval. The interval is 0, 2 pi or minus infinity to plus infinity. So evaluating the definite integral. Definite integral means completely closed integral. Okay, so this satisfies three conditions is called as contour integration. First one is the integral is complex integral. Second one is the curve is completely closed. Third one, the integral is completely closed interval 0, 2 pi to or minus infinity to plus infinity. Okay. Complex integration. Next one is can discuss about that contour integration can be classifying into two types. So okay, let's say the contour integration can be classifying into two types. Okay, so type 1 integral over 0 to 2 pi f of cos theta sin theta into d theta. So here where f is a rational function in cos theta and sin theta. Okay, so first type is an closed interval 0 to 2 pi f of cos theta comma sin theta. Here f is a function. That function is a rational function. The function is cos theta or sin theta. Anything else? So here we can take the circle modulus of z equal to 1. So here center 0, 0 and radius is 1. This is an type 1. Okay. Next, type 2. Type 2 is nothing but integral over minus infinity to plus infinity. Numerator is p of x, denominator is f of x into dx, where p of x and q of x are polynomials. Okay, so here we can take the circle as we can take the upper semicircle. Okay, the type 1 as in the circle, we can choose the circle is modulus of z equal to 1. Here x-axis and y-axis, center is 0, 0 and radius is 1. So here is 1, 1, 1. So radius is 1, so we can draw the circle. Okay. So r is equal to 1, the modulus of z equal to 1. Suppose given problem is 0 to 2 pi, we can select the circle as modulus of z equal to 1. Very clear? Next, type 2. Type 2 is a given problem minus infinity to plus infinity or plus 0 to infinity. Anything else, we can choose the circle as upper semicircle. So upper semicircle is means that here is an x minus x is an plus y. We can choose upper semicircle. So it's then radius r minus r. This is a type 2 problem. Okay, are you clear what is means that contour integration? The contour integration is classifying into two types. First one 0 to 2 pi. Second one minus infinity to plus infinity. Are you clear? Let's solve the problem. Okay. Are you clear that problem? Contour integration means that the complex integration along the scroll curve using in evaluating the definite integral is called contour integration. Are you clear? So contour integration is satisfies three conditions. The given integral is an complex integration. Second one, completely closed curve. Third one is an definite integral. Okay. Thus contour integration is classifying into two types. First one 0 to 2 pi. Second one minus infinity to plus infinity. Okay. So in this contour integration, take some notes. Okay. Note 1. Note 1 means denominator. We can solve the problem easily. So only we can choose the denominator. Cos theta. Suppose denominator value is cos theta. We can convert z square plus 1 divided by 2z. And suppose sin theta equal to z square minus 1 divided by 2zi. Okay. Next, note number 2. This is a note number 1. Next one, note number 2. Note number 2 is an numerator values. Numerator value. Suppose in a problem given to numerator value something else. Suppose numerator value is d theta. We can convert dz by iz. Okay. So denominator value is 0 to 2 pi. I am telling that first type 1 value denominator is cos theta means that you can convert this one. Z square plus 1 divided by 2z. Suppose denominator value is sin theta, you can convert z square minus 1 divided by 2zi. So next, numerator value is d theta. You can convert dz by iz. Okay. So let's on the working rule, how to solve the contour integration problem. So by using working rule, we can easily solve this problem. Okay. Working rule. Step number 1. Step number 1. First step you can doing that transforming the variable theta in terms of z. Okay. Step 1 is transforming the variable theta into z. Okay. Theta term, given problem is theta, you can convert z. So by using this, note. Okay. Next, step number 2. Step number 2, converting the given integral into the contour integration. So is means that given integral can be converted to contour integration. Okay. Next step number 3. Step number 3, to find the poles are inside or outside. Next step number 5, to find residue. Step number 5, evaluate under over C f of z dz by using Cauchy residue theorem. Next, step number 6, to find the value of the given integral. Okay, so discuss step by step. First one, transforming the variable theta in terms of z. It means that given problem is theta. You can convert to in terms of z by using note number 1 and note number 2. Okay, are you clear? So next, converting step number 2, converting the given integral into the contour integration. So it means that given integral is 0 to 2 pi. Numerator is d theta, denominator is cos theta or sin theta. Suppose cos theta or sin theta, you can convert into the contour integration. The contour integration is integral over c. C is an closed interval. So contour integration, given integration converted into contour integration. Contour integration is an c is an closed curve. Next to step number 3, to find poles are inside or outside. The poles is inside or outside by using circle. Circle is modulus of z equal to 1. Center is 0, 0. Radius is 1. Okay. Next, step number 5, step number 4, to find residue. Residue is in two types. First, pole of order is 1. Pole of order is 1. Next, pole of order is 2. Okay. So next step number 5, evaluate integral over c f of z dz by using Cauchy residue theorem. Cauchy residue theorem says that integral over c f of z dz equal to 2 pi I sum of residue of f of z. Okay. Last one, step number 6, to find the value of the given interval. So you can solve the problem by using working rule. We find the solution easily. Okay. So solve first problem. Problem number 1. Problem number 1. Problem number 1. Evaluate integral over 0 to 2 pi d theta divided by 13 plus 12 cos theta. Okay. Can solve this problem by using as a working rule. Solution. Step number 1. What says that step number 1? Transforming the variable theta into z. So how to convert the theta terms into z? By using note number 1 and 2. Okay. So is the problem, numerator is d theta. D theta value is equal to dz by iz. Okay. And denominator value. Here denominator is cos theta, numerator is d theta. So cos theta equal to what stays that cos theta value z square plus 1 divided by 2z. Okay, substitute here. Cos theta is equal to z square plus 1 divided by 2z. So step number 1 is over. So next step number 2. Step number 2, converting the given integral into the contour integration. Contour integration. So you can write given integration as integral over 0 to 2 pi d theta divided by 13 plus 12 cos theta. Okay, which is equal to integral over c. You can convert the theta in terms of z. So d theta is equal to dz divided by iz. Divide by 13 plus 12 cos theta value is equal to z square plus 1 divided by 2z. You can simplifying in this term. So step number 1 is over. Step number 2, you can convert contour integration is converted into the value and simplifying in this term. So here 2 and 12 is cancelled, we get 6. Okay, here dz by iz is an taking denominator value. So you can write dz by iz into 13 plus 6 into z square plus 1 divided by z. Okay, so next step, you can 6 is outside, you can multiple with inside value. So 6 into z square, 6z square, 6 into z, 6z. So integral over c dz divided by iz. So 13 plus 6z square plus 6z divide by z is an only 2 terms. So next step you can multiple with 13 into z means that commonly divided by z. So integral over c dz divided by iz into 13z plus 6z square plus 6 common divide by z. Okay, so you can cancel denominator is z, numerator value also z. So I is an imaginary value, so you can take outside of the integral. So 1 by I integral over c dz divided by, you can write orderly. First is an z square, second is z, third is a constant term. So 6z square plus 13z plus 6. Okay, so next step you can take the factorization term. Reason factorization means 6 into 6 is an 36. You can multiple with 36 and adding 13. How to convert 9 into 4? 36. So adding this term 13. So you can write this term. How to write? 6z square plus 9z plus 4 plus 6. So next step, what will we do? 1 by I in our lower C, dz divided by 6z square plus 9z plus 4z. The last term is 6. Okay. So do that. 1 by I in our lower C, numerator is dz, denominator is 6z square plus 9z plus 4z plus 6. Okay. So next term, how to simplifying this term? So here, so common term. In two term, in common term is taking outside. So common term is z and 3 is taking outside. So in common term is 3z. So remaining two terms we can take the common term 2 only. Yes, 2 only. So dz divided by common term is 3z. So taking outside. So remaining is 2z. So 3 into 2 6. Z into z square. Plus 9z. 9z means that 3. 3 into 3 9 into z. Plus in this term 2 term taking common value is 2. 2 means that 2z plus 3. So here 2 into 2 4. 2 into z, 2 into 2z value 4z plus 2 into 3 6. So how to write this term? 1 by I in the lower C, dz divided by 3z plus 2. Next one is only write 1 times 2z plus 3. Okay. This is an last term. So only we can take 1 by I. This term cannot be simplified. So you can write 1 by I in the lower C. The whole term is f of z dz. Where f of z equal to what's that? 1 by 3z plus 2 and 2z plus 3. So step number 2 is over. So step number 2 is what you do? Step number 2, converting the given integral into the contour integration. Okay. Integral over 0 to 2 pi is then given integral. You can substitute the value by using step number 1 and simplifying in this term 1 by 1. We get the value is dz divided by 3z plus 2 into 2z plus 3. Okay. So step number 2 is over. So next step number 3. Step number 3, to find poles are inside or outside. How to find the poles? So here 3z. How to find the poles? So here 3z equal to minus 2, z equal to minus 2 by 3 and z equal to minus 3 by 2. Okay. So here z equal to minus 2 by 3. Minus 2 by 3 value is minus 0.666 s. Okay. These values are is a pole of order. Order is 1. This is also pole of order. Is a pole of order 1 lies inside or outside. Given circle is center is 0, 0, radius is 1. Modulus of z equal to 1. The radius is 1. Center is 0, 0. So here the value 0.666. So 0.66 value is equal to here 0.666. Okay, minus means minus 0.66 is an lies inside on modulus of z equal to 1. So next you can write next pole z equal to minus 3 by 2. This value is minus 1.5 is a pole of order. Pole of order is 1. This is a pole of order 1. Order is pole of order 1 lies outside or inside. Minus 1 pi. This is and radius is 1. Okay. So 1.5 means this value is 1.5. So is lies outside on modulus of z equal to 1. Okay. Step number 3 is over. Step number 3, only you can find poles inside or outside. Next step number 4, to find residue. How to find the residue? By using residue formula. Pole of order 1. So here pole of order is 1. So by using formula, residue of f of z comma z naught, which is equal to limit z tends to z naught into z minus z naught into f of z. So here z naught value is n, pole is inside. So this value is an z naught value. Okay, so next one f of z. F of z is an 1 by 3z plus 2 into 2z plus 3. Okay, substitute here. So residue of f of z 1 by 3z plus 2, 2z plus 3, comma, z naught value is inside value minus 2 by 3, which is equal to limit z tends to minus 2 by 3 into minus z naught. Z naught value minus 2 by 3. Another one is f of z. F of z value 1 by 3z plus 2 into 2z plus 3. So next step is simplification. So here the limit z tends to minus 2 by 3. So here minus into minus plus. So z plus 2 by 3. Next one, f of z value same like as 3z plus 2 plus 2z plus 3. So next step, you can cross multiple of this term. Okay, the limit is same, you can cross multiplication. So limit is same, z tends to minus 2 by 3. You can take the cross multiplication. Cross multiple value is equal to z into 3 plus 2 by 3. So 3 into 2 divide by what's that? 3 into f of z value. F of z value is equal to 1 by 3z plus 2 into 2z plus 3. Okay, so here cancelling term is cancel term. Numerator is 3 by z plus 2. Denominator also 3z plus 2. So cancel this term. So remaining term is limit z tends to minus 2 by 3. Remaining term is cancel this term. Remaining term 3 into 2z plus 3. Okay. Next one, what will be to the next step? You can substitute z value is minus 2 by 3. Okay. So only cannot next step, you cannot write limit value. Only substitute here 1 by 2 into z value minus 2 by 3 plus 3. Okay. You can multiple with these terms. So 3 is common. So take outside. Multiple of this term minus 4 by 3 plus 3. Okay. Can cross multiple of this term 1 by 3. The cross multiple is 3 into 3 plus 9 whole divide by 3. So here cancel 3 3 getting cancel. Subtraction of in this term plus 5. Okay. So this is an residue value. Residue value is equal to 1 by 5. So what step is over? Step number 4, to find residue. Residue value is equal to 1 by 5. Okay. So next is step number 5. Step number 5. Evaluate in the lower C f of z dz by using Cauchy residue theorem. Okay. The Cauchy residue theorem means in the lower C f of z dz equal to 2 pi I sum of residue of f of z. So here 2 pi I is same. The lower C f of z value is equal to what's that? F of z. F of z equal to 3z plus 2 into 2z plus 3. So write f of z value 1 by 3z plus 2 into 2z plus 3 into dz, which is equal to sum of residue of f of z. is then residue value is equal to here residue value. What's that residue value? 1 by 5. So substitute here the total value 2 pi I divided by 5. Okay. So next last step number 6. Step number 6. To find the value of given integral to find the value of the given integral. So given integral is equal to integral over 0 to 2 pi d theta divided by given integral value. What's that the given integral value? Given integral is the given problem. Integral over 0 to 2 pi d theta divided by 13 plus 12 plus cos theta. So 13 plus 12 into cos theta. Okay. So which is equal to the given integral, which is equal to the value, the right hand side value, integral over 0 to 2 pi d theta divided by 13 plus 12 cos theta. The given integral which is equal to 1 by I integral over c f of z into dz. So write it. The same value 1 by I integral over c f of z into dz. So here 1 by I integral over c f of z dz value is equal to 2 pi I divided by 5. So here I getting cancelled. The balance value is 2 pi by 5. So 2 pi by 0 to 2 pi d theta divided by 13 plus 12 cos theta value is equal to 2 pi by 5. This is an answer. Are you clear this problem? So you can clearly note that you can first write step by step. Okay. Once again repeated that problem. Problem is given. Step number 1, transforming the variable theta into z. So numerator and denominator value. Step number 2, convert the given integral into the contour integration. So given integral is write as, you can substitute the step number 1 value and simplifying in this term we get 1 by I dz divided by 3z plus 2 into 2z plus 3. This cannot be simplifying this term, so you can write this term as an f of z. So next one, step number 3, to find pole. So pole is 2z value. You can find the z, and the second term also z. The poles are inside or outside. You can find inside value only residue. The residue value is equal to 1 by 5. Next step number 4, evaluate the given integration by using Cauchy residue theorem. We get the answer 2 pi by 5, and given integral into the value 0 to 2 pi d theta divided by 13 plus 12 cos theta, which is equal to 2 pi by 5. Are you clear? The same procedure applicable to problem number 2. So shall we move to problem number 2? Problem number 2. Evaluate integral over 0 to 2 pi d theta divided by 13 plus 5 cos theta. Solution, you can write step number 1. Step number 1, transforming the variable theta into z by using note number 1. Numerator is d theta value dz divided by iz, and denominator value is cos theta value is z square plus 1 divided by 2z. Okay, step number 1 is over. So next, step number 2. Step number 2, converting the given integral into the contour integration. So given integral is 0 to 2 pi d theta divided by 13 plus 5 cos theta. You can convert it in the term integral over c. dz value is equal to dz by iz. So we can write dz by iz. And denominator cos theta value is equal to z square plus 1 divided by 2z. So 13 plus 5 into z square plus 1 divided by 2z. Okay. Next step, you can simplifying in this term. 5 is multiple in this two terms. 5 into z square, 5 into 1. And numerator of iz is take the denominator. So integral over c dz divided by iz into 13 plus multiplication of this term 5z square plus 5 divided by 2z. Can cross multiple of this term. So cross multiple of this term, we get 26z. So write it integral over c dz divided by iz is common is outside. So 26z plus 5z square plus 5 whole divided by 2z. So here numerator z and denominator is z getting cancelled. You can write next step order wise. First one is z square, second one is z, third one is constant term. So I is an complex number, so taking outside of the integral value. So 1 by I integral over c dz divided by, you can write orderly 5z square plus 26z plus 5. Okay. You can factorize this term. 5 into 5, 25. 25. Multiple of this term 25, adding this term 26. So how to write this term? 25 into 1, 25, adding this term 26. How to write this term? 5z square plus 25z plus 1z plus 5. Okay. So write it 1 by I under over C dz divided by 5z square plus 25 5z plus 1z plus 5. Okay. In two terms, the common term is 5z. In two terms, common term is 1. Okay. So here 1 by I is common. So taking outside, numerator is dz. So taking right dz and denominator is 5z square plus 25z. The common term is 5z. So taking outside, how to write? 5z is taking outside means z plus 5. Because 5z into z, 5z square. 5z into 5, 25z. So taking on means z plus 5. Okay. How to write? Z plus 5. Z plus 5 plus 1 into z plus 5. So you can write dz divided by, this is an first term, the same, this is also like same, so write 1 times 5z plus 1 into z plus 5. Okay. So in this term cannot simplify. So you can write, cannot be simplified. So you can write it, you can write it 1 by I under over C f of z dz, where f of z equal to 1 by 5z plus 1 z plus 5. See here 2 is continuously in this term. So 2 is denominator. You can reciprocal of this term 2. 2 is as a denominator, reciprocal of this term. So you can write 2, 2, 2. So f of z is equal to this one. Okay. So you can find the pole are inside or outside. You can find the poles are inside. Step number 3. Step number 3 is what's that? Step number 3, to find poles are inside or outside. To find poles are inside or outside. So here poles 5z equal to minus 1, then z equal to minus 1 by 5. So here z equal to minus 5. So hence z equal to minus 1 by 5 equal to minus 0.2 is a pole of order. This term is pole of order 1. Pole of order 1 lies inside or outside. You can draw the diagram. X-axis, Y-axis. Modulus of z equal to 1. The radius is r equal to 1. Center 0, 0. Here minus 0.25. Here minus 0.25 lies inside. Inside on modulus of z equal to 1. So second pole z equal to minus 5 is a pole of order 1 lies outside or inside. Z equal to 5. Here z equal to minus 5 lies outside on modulus of z equal to 1. So next step number 2, to find residue. To find residue. The residue formula is residue of f of z comma z naught, which is equal to limit z tends to z naught minus z naught into f of z. You can substitute f of z and z naught value inside value one substitute here. So residue of f of z 1 by 5z plus 1 z plus 5 comma z naught value minus 1 by 5. So substitute here. So limit z tends to minus 1 by 5 z minus z naught value minus 1 by 5 into f of z. F of z is equal to like as 1 by 5z plus 1 z plus 5. So here minus into minus plus. So limit z tends to minus 1 by 5. So z plus 1 by 5. So you can write the same step. 1 by 5z plus 1 z plus 5. So limit z tends to minus 1 by 5. Cross multiple of this term, we get 5z plus 1 divided by 5. Then 5z plus 1 into z plus 5. So cancel this term. 5z plus 1, 5z plus 1. So remaining term, limit z tends to minus 1 by 5. 5 is remaining. So 5 into z plus 5. Next step, you can substitute z is equal to minus 1 by 5. So 1 by 5 into z value is equal to minus 1 by 5 plus 5. So substitute and simplifying in this term. 5 is common. Cross multiple of this term. minus 1 plus 25 divided by 5. So here 5 getting cancelled. Subtraction of in this term 1 by 24 is an residue value. This is an residue value. This is step number, what's that? Step number 4 is over. Next, step number 5. Evaluate del over C f of z dz by using Cauchy residue theorem. Cauchy residue theorem, del over C f of z dz is equal to 2 pi I sum of residue of f of z. So here f of z is equal to was that f of z plus 1 into z plus 5. dz is equal to 2 pi I into 1 by 24. Cancel this term 2 and 24. We get pi I by 12. Okay, the last step. Step number 6. To find the value of given integral. So given integral value is integral over 0 to 2 pi d theta divided by 13 plus 5. What's that? Given integral is equal to 5 cos theta. 5 cos theta, which is equal to, in this term equal to 2 by, in this term equal to 2 by pi integral over C. Here that 2 by pi integral over C f of z into dz. So given integral is equal to this one. Okay. So 2 by I integral over C f of z value is equal to this term. So substitute here pi by 12. So cancel this term, I getting cancelled, 2 and 12 is getting cancelled. Get the value pi by 6. So 0 to 2 pi d theta divided by 13 plus 5 cos theta is equal to pi by 6. Okay. So thank you so much. So in this class, first one, what is mean by contour integration. Second one, contour integration can be classifying into 2 types. Third one, you discuss 2 problems. Okay. Thank you all.